like GDB or let's say Geethra. You look at the decompile code in Geethra, you'll see that at the top you'll have the higher addresses, and then from there it'll go lower to lower to lower. Like as you go down, you get lower. If you look at the assembly instructions, the stack will be subtracted from the base pointer. The base pointer will be at the top, and then everything else will be subtracted from it. The subtraction is basically going down, which is from going top to bottom. Um, if you look here. So, okay, so what we'll be doing today is in red to win function or uh, red to shell code, we'll basically be rewriting the return instruction pointer. So we'll get to that in a bit. See, so in 32-bit architectures, the variables will look like $EBP and ESP, and in 64-bit, it'll change to RBP and RSP. The EBP is the base pointer, and ESP being the stack pointer. So I think you guys have already learned GDP. You guys would have seen this before. So yeah, this is one example of a buffer overflow. It's not really doing anything, but see, so I'll go back to. So in this, um, see, so in this, when you're inputting the first 10, uh, 1 second. Yes, you'll skip through that. That's you'll get to know that in red to win itself. I'll just skip to red to win part. 1 second. So, yeah, so today we'll be going through something called NDNS also. In I'll see, just use Geeks for Geeks, look into Indianness later on. It's not very important. We'll be working with Little Indian binaries today, but in CTF questions, this is something that might trick you. They'll give you big Indian binaries instead of Little Indian. There's a small convention difference in that. Basically, instead of the most significant digit being on the left, it'll be on the right instead. It'll just, the order will swap. So look into that on your own. Just Google Indian SNC. You'll get a Geeks for Geeks link. So yeah. Okay. So this is an example that was taken from someone named Ironstone. I'll send you the link in the Teams later, like after the session. So we'll be going through how to solve a red to win question today. So what red to win is basically you buffer flow buffer overflow and then rewrite the return instruction pointer with the address of the flag that you want to point to. So what will happen is your return instruction pointer will now have the address of this function named flag, which is known as the win function, which is why it's called read to win. So this buffer will be overflowed, and then this the return instruction pointer, which is somewhere here in the bottom, it will have the address of this function flag, which um, even though this is executing only this function unsafe, we will be making it execute this function flag, which is it's not supposed to do. Like this is not called anywhere in the C code if you check, but that is what we're going to make it do today. So that's called read to win. So yeah, first you'll have to figure out what the padding is to get to this function from the buffer. Uh, so this unsafe function is called first, which now it allocates 40 bytes here. So it have you guys wants to. See, this is the site, okay? I'm not. I understand. So you can get the files from here. I'll just screen share to you my terminal and solve the question for you guys. One second, guys. I'll start sharing my terminal in a bit. I think you should be able to see my terminal now. Right. You guys will also be learning something called con tools today, which I will go for in a bit. See, um, so the code we have here is an unsafe function with a buffer of length 40 defined here. It is just print and scan if basically it puts and gets. It's not. This is a 32-bit. We've compiled this at 32-bit by the like um, the binary we have here is 32 bits. I've just written this explained. So we have this main calling this function, and then this flag function is what we want to execute, which isn't called at all. And keep in mind that this is indeed a 32-bit binary. So we first decompile this. So if you look here, unsafe is called at some address 0804911B. Below or somewhere below this, you'll have the um, what function is that called? The win function will be here. The flag function will be here. So we first find the address of the flag function that we want to get to. Like we basically want our return instruction pointer to to point to this new function that we want to execute. So this function, this flag is at 0x0804911C3, which is what we want to execute. So uh, the concept, what we're going to do now is we're going to buffer overflow to the return instruction pointer and then override the return instruction pointer with this address. And we're going to use something called pawn tools to do this. Um, pawn tools is a zoom. Oh my bad. Okay. Sorry if you guys couldn't see the text. I hope it's clear from now on. I'll just show you guys the code again. Someone just told me that they couldn't see the just the code, yeah. Just take a look at the code. Yeah, or do you guys have any doubts so far? Put it in chat if there's anything. Or if there's no doubts, that's fine too. Just tell me. Wait, did it zoom in? Wait, it didn't zoom in. Did it zoom in now? Oh, fine. Okay. Yeah. Very good. 1 second. I'll just show you guys some pawn tools documentation so that you guys. So almost all in every CTF, all the exploits that you guys will be doing, you will be writing a Python script using this library called pawn tools. Okay, I'll just show you guys that. Oops. Okay, yeah. This was made by some guy named Gallops led. But, yeah, so basically what this does is, okay, so here, this example, they're running a remote, they're netcatting to a remote server. We'll just be doing, in ours, we'll be like, you can also use this to exploit things offline. This is connecting to a netcat server, exploitme.example.com at port so and so. Do install this. Just do Python pip install on tools. I think it should work. Or just get to the site and follow. So for our question that we have in this, can someone figure out? Um, okay, the first thing we'll be doing is figure out the padding. Okay, the padding is basically spamming a bunch of letters called debrowser sequence. Not sure how it's pronounced, but you'll basically just enter a bunch of capital A's, let's say, which has an ASCII value of 41. In hexa, it has a value of 41, so that will help you. Like when you decompile using GDP, it will help you like tell until where you come. So you're basically brute forcing into getting the padding, or you can just subtract both the addresses. With practice, you guys will get that. So I think that was covered already. So I'll skim over that. Wait. Oh, so this is how a stack frame looks. Um, you have all the arguments in the higher addresses, and then you'll have your base pointer here, and subtracted from that your stack pointer. Like so, when you let's say you initialize a buffer in the uh, when the stack grows, it basically subtracts a value from it subtracts address from the address of the base pointer. So that um, oh wait, I'm not sharing my terminal one sec. I hope you can see the terminal. So we'll start writing our pawn tool script to exploit this uh, code. So our goal is to basically get this binary to print exploited. In real life situations, this is maybe some secret code, let's say a password, or it's someone's. In some applications, you might have like some secret, like some confidential information stored, like maybe your Aadhaar number in some DigiLocker, let's say. And if it's a binary and it's not protected well, this happens. There are very popular, like in huge databases, sometimes they make small mistakes and these end up being bugs. And sometimes they lead to huge losses in the company. If you read the news regarding cybersecurity and stuff, you'll be able to see this. Okay, so first, what you have to do is figure out the padding between the the base pointer to the function flag. Okay, so um, one second. Yeah, back sir. Um, So the first thing you'll do is find the padding, right? So for this question, the padding will be, are people still joining? Yeah, for this question, the padding will be 52. This you can calculate by, so the buffer will be 40, and then you have to override the RBP, which will be 4. Like this you guys should be able to do using GDB. So I'll let you guys do that. I'll give you guys the file so that you can try it out later. Like after the session, just go try it out. Okay. So right now we are at, so this a into 52 brings us to the function. Okay, so we're about to write uh, the instruction pointer. So we want to replace the instruction pointer with the address of this function. This function being flag which prints exploited. So just copy this. See, since it's a, so P32 is something that comes under controls. Okay, so the binary that we're using is little Indian. Indianness. Those I'll go through Indianness in a bit, but this one will, most binaries that you'll go through will be little Indian. But some questions have big Indian to put you off. But if you see a binary exploitation question, just do check if it's, do check the Indianness. But yeah, it will probably save time when. One second. So this is the address of the function which I'll put. Uh, so that is the payload. So now what we want to do is send this payload to the function, right? So Pontoos has this. Pontoos has a function called send line. So we've defined P as our process. So we'll do P dot send line, and since we have the payload in this variable, we just do. Um, so this should ideally give print exploited to us. To bring it out, I'll p dot rec v. Let's see. I have. Okay. One second, please. Ah, so this B, what this B does is, so Uh, Before this, when I executed without the B, uh, we got a type error rate can only concatenate string, not bytes to string. So what this B does is it makes the payload return in bytes rather than uh, in as a string. Like if you just do A into 52, it will just give you 52 A's, but now it will be in bytes. So the padding, so that's pretty much what we're doing with this also. Like we're converting these A's into bytes and then adding them to this address, this P32 function. Do uh, instead of instead of this P32, you could also do um, this is the equivalent to um, x0 x04 slash 91 slash 63. I'll not go into why this is reversed. It's because of Indianness. Because of Indianness. We'll go into that in a bit. So this should work. The recre isn't working. I'll use. So yeah, so we've basically successfully gotten the exploit. So what we're doing is this is the padding, the 52 A's in form of bytes, and then the address of uh, address of win function. Win function here is the flag rate. So basically, what the win function means is you return to it to win. So return to it being making the return instruction pointer point to that particular function. So there is something called Pond 101 in Try Hack Me. I don't know if you guys have heard of that yet, but now you should be able to solve the level Pond 103, which is basically red to win again. Do try it out. I'll send the link. I'll send the links in the teams and channels after the session is over. Is there any doubts so far? Or, see guys, so the pawn tools part, it might look a bit complicated right now, but it's not much. It's most of it is just see this payload part is pretty much what this is your input. Okay, this payload is your input. Let's say I'm running slash. So here in overflow me, it's asking for an input, right? That payload is your input. So you can see it can be buffer overflow because of the segmentation fault. So um, whenever you input whenever you have a large input, you give a binary a large input and it returns a segmentation fault. It means that it can be buffer overflow. So your first instinct should be to check buffer overflow if this ever happens in any question. Um, And yeah, what we're doing is we're basically making sure it doesn't segfault, and we're choosing the correct padding, and then exactly overwriting the instruction pointer to point to the function that we want. So what we'll be doing next is looking at read to shell code. So this is when we don't have this function. We don't have the uh, flag function, let's say, but we want to execute a shell, somehow get access to a shell using the vulnerable code. So what we'll be doing is we'll be executing our own uh, shell slash function using buffer overflow. So I'll show you guys that. So this is basically what we saw so far, where we use like you guys do this, and you'll basically just be using GDB to get the disassemble code, which we saw, and then get the offset. To get the offset, you can do things like printing uh, you can print the instruction pointer itself after placing a breakpoint at main. I'll actually show you guys how to do that. You guys would have had that in the previous session also, I think. See, so showing you my terminals, right? Yeah, GDB rectangle. So I'm placing a breakpoint at main and then running it. So nothing has been called so far. No function has been called so far. And then you can do x/x EIP. This is at main. So if you do x/100x $EIP, you'll find this. So when you give your input, you can come here. So if you give a bunch of A's, you'll be able to see. Um, so you'll be seeing 41, 0x 41, 41, 41, 41. Using that and using how many number of A's you've given, you can pretty much predict what the offset is. So I'll let you guys do that part. Should be easy. You just use. You can also use stuff like Radar 2 and Geethra. Radar 2 is a command line interface for reverse engineering. which I have started using recently. So I like it. But there are a lot of tools, right? So GDB is the most popular one or most commonly used. And then there are stuff like Ghidra, which is a reverse engineering framework, which which can also be used for stuff like these. Like so, pawning, so binary exploitation and reverse engineering have a lot in common. So you guys, after if you attend all these 9 sessions and like solve questions based on them, you'll kind of be able to do reverse engineering also. Like a lot of reverse engineering you can do by just using GDBs. You don't really need Ghidra. The basic questions at least, and then you can slowly get into Ghidra as well. Those are just tools that you'll slowly get used to. Um, so yeah, I'll link you guys this website in a bit. So this is Debrujon sequences, basically just the inputs. So even this guy uses radar 2, I guess. Yeah, he uses radar 2 to do his stuff. Uh, so yeah, so what we'll be looking at next is red to shell code. Here we won't have this win function, so we'll be running our own code. So we could have done that in the previous code also, but it's so in red to win you'll only be able to execute what is there in the code. Right? So let's say there's something called print password, but that's not very common. So in red to shell code you can like run your own code. So generally it spawns a shell. Uh, I, you guys know what a shell is? A shell basically gives you access over all the files, and you'll basically have root access over everything. Yeah, this will be the next code. This is pretty much just the previous code, but reduced. Um, well, see, so from this itself, I can tell you that the offset is going to be 312 because it's basically the previous code, but the buffer size has changed to 300. Right? So as you practice, which I'm not going to spoon feed you on this, but well, when you practice questions like these, you'll be able to tell the offsets pretty easily. So yeah, do try some questions. I'll link you guys a bunch of questions from Pico CTF and mainly Pond 101. It's in the site called Try Hack Me. So yeah, I can already start writing the exploit for this. Like so, the buffer is 300, and the remaining 12 is basically writing the base pointer and this function blah blah blah. Some bullshit. That stays the same for both the codes. So it's just previous for the previous code, the buffer size was 40, and the padding was 52. So here it'll just be 312. Um, So preferably don't uh, do this. What this does is disable ASLR. This is a safety measure that keeps your kernels and stuff. Okay, you'll learn what the ASLR is later. It's called address space layout randomization. It basically just keeps changing the address of functions and stuff inside the kernel so that exploiting it is very hard. You'll be learning this in like some of the, I think in the 6th or 7th session, you'll be learning ASLR. Next session, you'll be learning something called canaries, which canaries is a safety measure for buffer overflows. So in the binaries that we are using, there isn't any safety measure at all. Uh, Next, you'll be overcoming safety measures like canaries, ASLR, and then you'll be using stuff like GOT table, PLT, blah, blah, blah. Okay, that is the answer, I guess. So okay, I'll start writing the script for your second question. Shell code. This is also a 32-bit file because it was. See, so this first line is how it was compiled. Okay, gcc source.c os well. This is the name of the binary. If you guys haven't used GCC before, this O basically makes the name of the binary val. If you don't put O and you just do, let's say GCC source.c. Oh, yeah, my guess. I'll not mess around with that. But it'll instead say a dot out instead of one, basically. No pi is another safety measure, stack protector safety measure. This is basically this is basically removing safety measures so that we can practice questions. And then yeah, it's compiled in 32-bit form. The buffer is of size 300 here, so the padding will be 312, which is 312 A's. Okay, like um, this, you should be able to get in a bit. Then the same overflow me, and the same main is calling unsafe, but there is no flag function anywhere. So instead, this time what we'll be doing is running our own code using something called the shell script, which I'll show you guys. Oh, did I not? Oh, FFF, my bad. I didn't switch. I was teaching through the terminal, bro. Okay, I'll go through that again. But you guys can see the terminal, right? Okay. Teams just kicked me out, bro. So much. 1 second. See, so what I was saying was, I think you can see the terminal now. So yeah, so this is how the binary was compiled. The binary being this one binary. It was compiled with the flags O, which is for the name one. No pi is a security measure, which you will learn later. So no pi basically like it removes the security measure. Stack protector removed, and then your binary is compiled with 32 bits. So oh, I didn't put quotes. Okay, so the payload has the padding. So this will be the padding. I'll start with the padding. This will be 312 like we saw. Our buffer is of size 300. So our padding will be 312. This can be brute forced. So this 12 has a significance. You're basically just writing some of the pointers after the buffer, before between the buffer and the um, instruction pointers. There are some garbage flash, you know, base pointers and stuff, which you're overwriting with these 12 As, and then you'll be adding. So last time what we did was we added. Uh, Last time we added the address of the function that we wanted to override. Um, so now we'll be like um, also guys, after the session, do go try out on 104. Okay, those are the best challenges out there. We have, so I guess try hard. So these, yeah, like basically the site tryhackme.com/r/room 101. All these challenges are really nice. These two are very basic. You guys should be able to do it. This is red to win, if I'm not wrong, and this is red to shell code. Uh, shell code. See, so shellcode will look like /x blah blah blah. I'm just trying to find. Once I guess I'll go through what shellcode is first. So yeah, shellcode is a small piece of executable code used as a payload built to exploit vulnerabilities in a system. So it basically just runs a bunch of commands for you, which the program is not supposed to do. So in the first exploit that we did, read to win, we only executed the function that was already present. So in read to shellcode, what we'll be doing is executing commands that we are inputting. Like we will be choosing what to execute, and there is way more scope for this because we are not limited by functions that only the program already contains. Uh, so these are some examples. This I don't think you guys will be able to understand this yet, but uh, okay. I mean this one. See, so what happens here is this first example. Um, let's say I have access over a shell in someone else's computer. That basically means I can access all their files, delete all their files, send myself all their files, pretty much do whatever I want with that computer. So that is what spawning a shell in someone else's computer means, like the targeted system or the targeted machine. And there's something called privilege escalation. So if you successfully execute Windows privilege escalation malicious code, then you'll basically have admin access slash root access to their whole PC. So, yeah. Do try out Pond one. So I was trying to find the assembly version of shellcode so that I can show you guys how it looks. But I guess I'll just be going to. I think I'll just be using ASM. So ASM is ASM is this library that basically lets you use assembly in uh, Python codes and C codes. Like in C, it's underscore underscore ASM if I'm not wrong. And in Python, I think it comes as part of font tools. So and then now we have to figure out where to put this. So this is the shellcode, okay? Like CSM converts it to binary bytes. This is the shellcode. Shellcraft.sh is code to spawn a shell, and this ASM function converts it to bytes. The shellcode. This is supposed to come below. Now we just have to figure out which address to send this shellcode to. Um, to execute shellcode, ASLR has to be okay. I'm supposed to. So what I just did is I've removed ASLR from my PC. So my laptop is temporarily vulnerable to some exploits, but this is to basically run the exploit, right? So, so it's main. I'll set up breakpoint at main just in case. So we already know that the padding is 312. Now now what we're finding is the variable of the address of the local variable that gets printed out. So that would be My bad, guys. I'm back. Didn't even notice I got DC. Ramesh, yeah, just share my screen also. This is where I stopped with the exploit rate, adding in shell code. I'm assuming we didn't go to the address part yet. See, so this exploit is almost done. Okay, like, so what you have to do now is you just have to get the address to put this into, and then send the payload. You'll basically spawn a shell, which we'll do. Uh, we do something here, and then so figuring out this address, we'll use GDP again. This has meaning. This has, I'll put a breakpoint at main, and then I'll put a breakpoint after main. So I'll put it here. So now we run it. Continue. So I'll enter a bunch of A's here. Now what we want to do is we want to find these A's from the address of where these A's are stored. So x/x. See 100x prints 100 different things. I'll show you. So x/x dollar EBP. It prints exactly just EBP. Now if I do x/100x, it will print everything below it also. These are the higher addresses too. Now we want to find a bunch of 41s. The 41s are basically what I entered, right? So let's just do this. Um, say 100. You don't see anything. Do 200. Okay, yeah. So we see the 41s here. Wait. At 0xFFCCB8. So just copy this address. Put here. So this should pretty much be our exploit. So yeah, we got our shell. So if you see, that is pretty much our shell. So yeah. Wait, no, inside. 1 second, yes. Yeah, so that's pretty much the exploit. So I'm sharing the terminal right now. I'll share you guys the write up to this whole assignment in Teams right now. You guys can look through that. This is Ironstone's. He's used radar too. It's very similar to just if you want to follow it, just use the equivalence. Like I've sent you the write up to this exact function. He uses radar 2 in his write up. You guys can just use GDB's equivalent to those radar 2 functions. Radar 2 is a different reverse engineering tool. It's also a CLI, I think. CLI being command line interface. So I'll go through Indianness for a bit. For, um, so there are two types. One is Little Indian and Big Indian. Uh, it's, so the Indianness refers to the byte order used by a computer or microcontroller. So for electrical engineers, Indianness is very important. For computers, it's almost always Little Indian only. Um, so how it differs is the order of uh, the most significant digit to the least significant digit will be opposite in Little Indian and Big Indian. So yeah, so in Little Indian, the least significant byte is stored first or to a lower memory address. So basically, to the bottom or the right, let's say, and the highest byte, highest significant byte to the higher memory address. That is Little Indian, which is what uh, this is what most of the questions will have, and I think even let's say like our computer, since they're Intel x86, they're all Little Indian only. And Big Indian is stuff like, if I'm not wrong, RISC-V uses Big Indian architecture, where the most significant bit is stored first. Wait, what? So in Big Indian, the most significant part of the data comes first. In Little Indian, the least significant part of the data comes first. Like here you can see how in Big Indian 0 is mapped to 12 and 3 is mapped to 78, but in Little Indian 0 is mapped to 78 and 3 is mapped to 12. So when you're reading binaries after decompiling them in GDB or Githra, if they're you have to keep in mind if whether the binary is Big Indian or Little Indian. Because when you write your payload for bigger questions, your whole thing could go wrong. You'll probably have to rewrite the whole thing accordingly. Because Like wherever you've used addresses, all that you'll have to rewrite and it becomes a huge pain. One more thing you have to keep in mind is if whether the binary is 32-bit or 64-bit, that is also a very important thing to keep in mind because a lot of mistakes happen there. I almost didn't solve a question just because I didn't notice that the binary was 32-bit. I assumed it was 64. So, I'll send. Try solving these questions. You'll be able to solve even question task. You'll be able to solve till task 5. If you're not able to do or look at like the write-ups for this by uh, yeah, Raspberry overflow. Yeah, this guy has really good uh, write-ups. He uses a tool named Cutter, which is something written on another Ryzen. So Ryzen is a open source reverse engineering tool, and Cutter is something written on top of Ryzen. And this guy uses Ryzen. You can actually rather just use GDB or Gazera, but I guess you guys know GDB now, so GDB is preferred. So try these questions if you're not able to uh, watch these videos or look at some of the write-ups and just try to learn the concepts. I suppose. And there is this other site named Ownable Care. Um, this site, these are more challenging questions. So if you're done with one, you can start doing these. The first few questions are maybe easy, but it gets really hard eventually. These are like maybe Google CTF level questions, let's say, and that's one of the biggest CTFs out there. So, yeah. Do try these, and before the start of Pico CTF, these have really easy questions. This is a site hosted by Carnegie Mellon. Uh, it's called Pico Gym. So Pico Gym has like questions of previous year. Pico Gym has questions from previous years. So we'll try out these questions as well. So yeah, I'll. You guys can ask any doubts if you want. Like, is there anything that you guys want to ask? You just put a text in the chat.
Hello, am I audible? Hello.
Yeah. Hi.
Yeah, if anyone has any doubts, they can raise their hands and we'll let you unmute and you can ask. Yeah, Lavish.
Pralav Sharma, I've given you perms to unmute. So, oh, I mean, MD Tabish, you also have permission to unmute if you want to unmute. You can. Sanjay Sutar, I hope. Sanjay,
Hello. Hello.
yeah.
So, guys, can you revise it?
What?
Can you explain it again?
Wait, which part?
Before that, if
What are you saying?
I think he asked for a full recap. Before that, if anyone has any specific doubts, they can ask. Yeah, yeah, you. Uh, ESZHI, if you have.
Hello.
Yeah, yep. So I had a few doubts regarding my this entire meeting. I'm still unable to access any WhatsApp group or anything related to this cybersecurity course. So,
Oh, 1 second.
like,
I'll send you the link to the channel. There is.
yeah, even the channel is not
Yeah,
sorry, only the
yeah,
WhatsApp channel is accessible for me. I couldn't
yeah,
attend the
just that.
last session also since I didn't receive any link.
Oh,
The links will be sent in the general channel of the teams also, so you can join from there as well.
Yeah, the team
All
channel
the
is not available for me.
like see, you attended this session from the session 4 channel, no? When you clicked on the link, you came to Teams and joined this meet, right?
When I clicked on the WhatsApp channel, it's directing me to this. I'm able to access it through the Chrome browser, but otherwise, I'm
Yeah.
not. Any particular team is not being visible on the application team.
Okay.
There is an issue with WhatsApp channel too. Like we are not. I'm personally am not able to join the whatever it is, a community or a channel.
Yes,
Whenever I
yes,
click the link, it just go to the WhatsApp app and it just disappeared from there. So
yes,
there, I think there is
Uh,
some issue with the link. So can you recheck that?
yeah. And one
the
more thing.
channel link.
The thing is, yeah. Can I say?
Yeah, yeah.
Yeah, so the thing is, I had registered for the cybersecurity course, but somehow the Summertronics group has been registered, and that is showing in my team's among the registered list.
You will have to contact the coordinator for that. We don't know.
I even sent a
anything
mail
like
also, but I didn't receive any updates
Yeah,
on that.
I'll let CFI know. This is something handled by the CFI management. I'll let them know.
Yes.
Yeah, we'll get you.
Thank you very much.
And we'll make sure to send all the links in the WhatsApp channel itself from now.
Okay.
So, sorry for
Thank
the
you very much.
inconvenience.
No problem. Thank you. Thank you.
Fine, I'll end the session here. I am assuming no more doubts. See, to get more clarity on Red to Win and Red to Shell code, solve try hack me 103 and 104. Look at what's their write-ups and then try some Pico CTF questions without watching write-ups. I think that will really help. I'm saying try hack me specifically because the write-ups for the try hack me question by Raspberry Overflow are very in depth, in detail. He'll go through the memory allocation step by step. He'll go through pretty much every basic thing. So yeah, do watch them. If you have any more doubts, watch the session again, and I'll send the slides link also in the general teams and the WhatsApp channel. Take care, guys. Bye.
ना खुले यार. You are unmuted.